Alright guys, this is circular functions. Basically we're going to be doing a little bit more with the unit circle. So this next page is just a huge diagram, right? But important thing to note is that all of these are supposed to be on the unit circle, which I'm not very good at drawing, but I tried. So imagine that all of these points are on the unit circle, okay? And each of them are the same triangles, except they have different endpoints, right? And the only reason that they're different is because they switch from negative to positive, the x's and the y's. You all know how to find the sine, cosine, and tangent of each theta, but there's something, a pattern that should be pointed out. So for the first quadrant, all of the functions are positive. In the second quadrant, only sine is positive. And this is why in the last section, it didn't matter if you took sine of theta or sine of 1 theta minus 1 theta, 180 minus theta, you got the same sign, right? And in the third quadrant, the only one that's positive is tangent. In the fourth quadrant, the only one that is positive is the cosine. So when you're solving problems, it's helpful to memorize which one is positive and in which quadrant. It just makes it easier to visualize. So let's do an example. So what are the 4 angles where tangent of theta equals 1, tangent of theta equals negative 1? So let's look at when tangent of theta equals 1. I'm just going to do a quick sketch. I know that tangent is positive in the first quadrant and in the second quadrant, right? You have to be a little familiar with your special triangles. So anytime you have tangent of theta equal to 1, you're dealing with the 45, 45, 90 degree triangle. So theta is going to be 45. Okay, so that's one angle where tangent of theta equals 1. Alright, so got this one. Now, I can find this one, which is going to be our theta 2. And you can find that by just adding 45 to 180, and you get 225. Now, we talked about how when you're doing positive angles, you always start from the positive x-axis, right? But if you go counterclockwise or anti-clockwise, you get positive angles. Well, if you go clockwise, you're going to get negative angles. Okay, so this is negative 90. And then if I wanted to go 45 degrees more, I would be at theta, the third theta, which equals tangent of theta equals 1, which is going to be negative 135. And then the fourth theta is going to be at negative 315. And there's multiple ways of getting to these answers. You could go to negative 270, which is right here, and subtract another 45 or add another 45, whichever way makes sense to you. But yeah, so that's how you get those 4 different angles where tangent of theta equals 1. Where tangent of theta equals negative 1. So it would be the opposite quadrants where tangent of theta equals positive 1, right? So instead of the first and the second, we're going to be in the, or first and the third, we're going to be in the second and fourth. So these points, these thetas are where it equals a negative 1. So our first theta is going to be here, and that's going to be positive 135. Our second theta is going to come around, and it's going to be 315. The third theta, start from the negative side, you get negative 45. and then the fourth theta is going to be negative 225. Comes around this way. Okay, so I just wanted to show you how they kind of play off of each other. Notice 45, 45, 225, so on and so forth. Yeah, okay, so another example. Given that sine of 50 equals 0.766, and given that cosine of 50 equals 0.643, find the following. Now, in your book, if you look at this example, they like have you doing a bunch of weird stuff. I think that, yeah, we'll just go through it. So, cosine of 130 degrees. 130 degrees. So first we're going to do is figure out where that is on in our quadrants. So 130 is going to be in our second quadrant. We know that cosine is negative in this quadrant. So I take what cosine of 50 is, because 180 minus 50 is 130, so I know that they're going to have the same cosine, except it might be negative, and in this case it is. So this is going to equal negative 0.643. Same thing with sine of 230. First we're going to draw where that is. 230 is over here, or not over there, it's over here. And in this quadrant, sine is negative again. And I know that, just to make sure that I'm doing the right one, 180 plus 50 is 230 degrees. So I can use these, what was given to us. So sine is going to be negative, so you have negative 0.766. Cosine of negative 50. So cosine of negative 50 is going to be over here. Cosine in the fourth quadrant is positive, so it's going to stay the same as 0.643. Okay, and I think we have one more problem to go over. So this one's given in radians. So sine of pi over 3 equals square root of 3 over 2. Cosine of pi over 3 equals 1 over 2. Find the following. Sine of 4 pi over 3. So 4 pi over 3, I need to sketch where that is, and it's going to be over here. I know this because 3 pi over 3 is just pi, and pi is right here. And you add one more third, you're still in the fourth or the third quadrant. Sine is negative in this quadrant, so all I have to do is take square root of 3 over 2 and add a negative in front of it. Tangent of negative pi over 3. So sketch where pi over 3 is negative. It's going to be right here. Tangent in this quadrant is negative. So I take sine, which is pi over 3 over 2, and I put that over cosine, which is 1 over 2, because I know that tangent of theta is the same thing as sine of theta over cosine of theta, and we can't have a fraction within a fraction, so I simplify and I get square root of 3. It has to be negative. Okay, so that is our video. Have a nice night.